everybody. Hope you're doing good. I am going to go over the normal distribution warm-up. You should be able to find it in your attachments. It's also in your packet that I sent home. If you want to go over this with me, it's just a good example to remind you how to do this. We're going to talk about some empirical rule, and we're going to talk about some z-scores to remember how to do this. Okay, Algebra 2 normal distribution warm-up. For a summer job, Micah is running a machine that fills peanut butter jars. The labels on the jars say that they contain 18 ounces. The machine fills the jars so that the distribution of weight is normal with a mean at 18 ounces and a standard deviation of 0.5 ounces. We're going to sketch the graph of the distribution of weight below. Make sure to label the horizontal axis correctly. Okay, so the first thing we're going to do is make that normal distribution arc here. So we know that the mean in the middle is 18. So that's our highest point in our curve, normal curve. And then we're going to do a standard deviation of 0.5. So we're going to go up 0.5. We get 18.5. We get 19. And we're going to get 19.5. And we're going to stop at 3 standard deviations away. So we're going down right here. Okay. Then we're going to go in the other direction, and we're going to go 3 standard deviations below. So we've got 17.5 is our first one, 17, and 16.5. Okay. So it's just going down. Okay. So first we want to know what percentage of customers will get jars that weigh less than 18 ounces. Sorry, this should look more like a curve and less like a point at the top, but you get what I mean. What percentage of customers will get jars that weigh less than 18 ounces? So that's literally how many will get this much. This is right in half of my graph, so it is 50%. We can also go ahead and look at the empirical rule handout, and we could add all of these up. We would also get 15%. 50%, excuse me, I think I said 15. What percentage of customers will get jars that weigh less than 17 ounces? So 17 ounces is right here. So I want to know these 2%. So right now, I am just going to go in and I'm going to take my empirical rule chart that I have, and I'm just going to fill everything in. Miss S did this for us in class at one point. Just kind of gives us an idea of what we're talking about. Okay, so we want less than 17 ounces. So we're going to add those two together, which gives me 2.35% and 0.15% gives me 2.5%. Yes, you can put percentage marks for each of these. Some of mine don't have room for it. What percentage of customers will get jars that weigh less than 19.3%? Do we see 19.3% up here? No, this is when we have to do our z-score at this point, because it is not a regular standard deviation. It's somewhere between, this is 1, 2, it's somewhere between 2 and 3 standard deviations away. So we're going to use that z-score formula, x, the number we're talking about, minus the mean divided by the standard deviation. So that's 19.3 minus, what's the mean? Right up here, or we can actually look in our problem that the mean is 18 ounces, divided by our standard deviation, 0.5. Okay. Remember, when you put this in your calculator, you want to do the top first, then divided by the bottom, or make sure you have that, you guys probably don't have a graphing calculator at home, but like in Desmos maybe you could do it, where you have that bar in between so it kind of knows that these are in parentheses, and then you do the bottom. And we get 2.6. Now 2.6 is the z-score. So this is when we need to pull out our z-score chart. And I know this is very small, but if we remember how to read this, we go down and we're going to go down 2.6, 0, and we're going to use this little number right here, which is 0.9953. What percentage of customers will get jars that weigh less than 19.3 ounces? 99.53. Okay. On our z-storage chart, it's at 0.9953, and we remember to get a percentage, we move the decimal place over twice. Okay. What percentage of customers will get between 17.3 and 18.7 ounces? Again, these do not come up here. It's not like a standard deviation. So we need to use the z-scores for both of these. So again, this is my x. I'm going to do that one first. So I'm going to go 17.3 minus 18, parentheses, divided by 0.5, and I'm going to get negative 1.4. At this point, I'm going to look it up on my z-score chart. Negative 0.140 is 0.0808. Okay. Now I'm going to look up 18.7 ounces. I'm going to find that z-score. This is now my x. So I have to do this problem beginning because it's in between them. So I'm going to go 18.7 minus 18 divided by 0.5. That gives me 1.4. And I'm going to pull out my z-score chart again and look up 1.4. Negatives are on this side. I'm looking up positives over here, 1.4, and I get 0.9192. Now I want in between, so I'm going to subtract 0.9192 minus 0.0808, and I'm going to get 83.84%. Again, I get 0.8384, move my decimal place over 2 times. Okay, F, this is the one we were working on right before school was canceled, so this is a little bit more complicated. We're going to look up 80% in my chart to figure out what the z-score is, to then work our way backwards. We've got x minus the mean divided by the standard deviation. We do not know what x is, but we also don't know what z is. We don't know what the z-score is. We just have the percentage. So we want to find x. We know the mean's 18. We know the standard deviation 0.5. And I'm probably going too fast, and I don't have anybody to tell me to slow down. So I'm pretending I'm hearing you say slow down right now. Okay? So all I did was plug all this in. I'm trying to find x. I don't know what z is. I want to find this number. So I'm going to look up 0.80. Now I moved the decimal place over this way twice to change it into a decimal, from a percent to a decimal. And I'm going to look in my z-score chart in the middle to find 0.80, and that's going to give me my z-score, which goes right here. And then I can solve for x. So, over here, I'm looking up 0.80. So I'm trying to find as close to 80% as possible. I think I'm probably right here at 0.84. See how it's 0.7995? That's really close to 0.80. So I'm going to make this equal to 0.84. Okay, now I've got to solve it. So I need to get 0.5 off from the bottom. So I'm going to multiply both sides by 0.5. These cancel. I'm left with x minus 18 equals, and I put this in my calculator, 0.84 times 0.5, making sure you put it in the calculator correctly, unlike I just did, and we get 0.42. Now what do I do next? Add 18. And I get 18.42 ounces if it's 80%. Okay? All right. We're going to go to the last one, G. What is the probability that a customer gets a jar that weighs 19 ounces or less than 17 ounces? Okay, so we can go back to our empirical rule for these because 19 and 17 are on our chart. We've got 19 here, so it's these, and we've got 17 here, so it's these. So I'm going to add them all together. That's 0.15 plus 2.35 plus 2.35. Can't see it, sorry. Plus 0.15. And that gives us 5%. So 5% are more than 19 or less than 17 ounces. All right, please leave comments. Let me know if it was too fast, too slow, if you want another one. What kind of things do you want more of? A, B, C, D, E, F, G, ones like those. I can look up new problems for you. I can add some more. Message me, tell me, write in the comments what you need. Thank you.